We're looking at the topic 1 practice test, and we're looking at the paper 2 questions. So 1A, you're going to see that each of these questions, 1, 2, and 3, carry through. There are several parts of the question, and they're all related to the beginning. So read the beginning of the question carefully. So we have a decomposition of guanidinium nitrate, and in this question 1, you're being asked to balance the equation for this decomposition reaction. So when we are balancing our equations, there are a number of ways you can do it, the way that I prefer, but you can do whatever gets you the right answer, is to separate out our elements. So we have carbon, nitrogen, hydrogen, and oxygen on each side. And the tricky bit here is figuring out our starting amounts with all of these crazy parentheses and subscripts and different elements showing up multiple times in the same compound or on the same side of the equation. So looking at this, we've got our carbon only shows up once on the reactant side, and it only shows up once on the product side. Our nitrogen, we've got 3 times 1 nitrogens, because remember our subscripts outside the parentheses propagate inside the parentheses. So we've got 3 nitrogens here, but also a 4th nitrogen here at the end with our nitrate. So make sure that you count all of the atoms of each element that are in the compound. Hydrogen, we've got 3 outside the parentheses times 2 inside the parentheses. That's the only hydrogen, so that's going to give us 6 hydrogens to start with, and our oxygens are going to be 3. On the product side, we've got our 1 carbon, we've got 2 nitrogens, we've got 2 hydrogens, and 1 oxygen. That's pretty straightforward. All right, so how are we going to balance this? It is not currently balanced for the law of conservation of mass, so we need to put coefficients in our equation in order to balance it, in order to make sure that we have the same number of atoms on both sides of the equation of all of our elements. So I'm just going to start with the easy stuff. I'm going to say, well, look, nitrogen, there's 4 on the reactant side and 2 on the product side. I'm going to put a 2 up here. That gives me 4 nitrogens. Make sure that you update your table. If you're doing the table approach, make sure that you change the coefficient first and then update the table so that you're not changing numbers and then forgetting to put the coefficient up. All right, so I can see that I am going to need going to need to fix my hydrogens. So I've got 6 hydrogens on the reactant side and only 2 on the product side. I can fix that by putting a 3 in front of the water. If I do that, that gives me 6 hydrogens. It also gives me 3 oxygens. And just like that, if I looked at my table, I now have the same number of carbons, nitrogens, hydrogens, and oxygens. If I want to fill in coefficients here, the coefficient for anything that doesn't have a number in front of it is just 1. So here's my balanced equation, and if you are given an equation to balance or something like that in the first part of a question, chances are you're going to be using that later, which means we're probably going to need to use the mole ratios. So keep that in the back of your head as we're going forward. All right, 1B says calculate the total number of moles of gas produced from the decomposition of 10.0 grams of guanidinium nitrate. All right, so that tells me I have grams and I'm going to need moles. That tells me that I'm going to need to calculate my molar mass because I'm going to need to, on my island diagram, go from mass to moles of one substance. And the guanidinium nitrate is my reactant, which means that I'm going from one substance, substance A, to substance B, which is moles of gas produced. And we're going to come back to that in just a second. So the first thing I'm going to need to do is calculate my molar mass. And I'm going to do that over here just because I have some space. And I've already figured out how many atoms of each substance I have in a molecule of guanidinium nitrate or a formula unit. So to find the molar mass, Again, this is not part of question A. I'm just using this space to calculate it. So I'm going to find each element on the periodic table. And then I'm going to multiply it by how many of that element I have per unit of my substance. So the same thing that we had to do when we balanced the equation, we're using for the molar mass, because the relative amounts, the relative masses of each element in the whole compound are important. So I can't just add up these numbers from the periodic table. I have to multiply them by how many of them appear in that formula. So carbon, we only get 1. Nitrogen, we've got 4. Hydrogen, we've got 6. And oxygen, we've got 3.